I want to again thank you for having us today. I want to especially thank Jim from Connecticut DOT and Andy Olson from NOLSA letting us know about this. We've been in the industry for a little over 7 years, and they've said, hey, you got to come down here and show what you're doing around electrification for this conference. So again, thank you for the invitation. And I want to share with you a little about Volta Power Systems. Again, my name is Jack Johnson, founded Volta in 2014 around the concept of how do you get electrification into smaller, more diverse markets. 20 years in the automotive industry, launched a couple $100 million lithium-ion manufacturing facilities, and I saw firsthand the challenge it's going to be for those small, task-oriented vehicle platforms to ever achieve the electrification goals that you see or hear about every day. So we are a leader in building advanced energy systems, and we'll talk about what that means, but basically it does involve lithium-ion, but on scale. But think about more replacing generator technology or engines or small engines, anti-idling. We have exclusive access to automotive-based technology, and there's a lot there, and I hope you come to the booth and we'll explain to you what all that's about. But our whole focus, again, is that small volume. We're in the RV industry, we're in the marine industry, and we're in the specialty work truck arenas, all with the goal of making power without compromise is a tagline. All of you have probably had electrical systems that haven't worked quite as equal to your traditional solutions, and we've been trying to make that not be the case anymore. So what does our systems look like? Well, the idea is scalability, flexibility. So we design and build everything here in the U.S. We're in Holland, Michigan, and we have about 30,000 square foot facility. We have over 50 team members, almost all of them automotive-based engineers, and we have built a scalable energy solution that pretty much can be expandable to meet any of your requirements from a 40 to 50 horsepower and down world. So if you can imagine here, we can scale your storage, which is like your gas tank. So if you need 6 kilowatt hours to 100 kilowatt hours, and if you don't know what that means, come on by, we'll talk about kilowatt hours and kilowatts. We can change the power. We can give you exportable 120 volt pure sine power, 208 three-phase. We can do 240 split phase on mobile applications, allowing you flexibility and expansion. We also have onboard generation. All of this works on your existing vehicles, so you can make your existing vehicles micro-hybrid capable, flexible, or integrate into new vehicles. We're even on top of electrical vehicles. As you heard earlier, when you talk about building an electric drivetrain, and then you say, hey, I want to add this BTO, or I want to add this device, or I want to have a cable puller, or I want all these other accessories, they all take energy. Well, you can't just go change your manufacturing line very easily when it comes to electrified vehicles to support that power demand when traditionally we just make bigger gas tanks. So those challenges, this is a method to make that those challenges go away. And again, we're going to walk you through a few examples, but first, think about the reality you're all facing, especially as fleet managers. Sustainability, you hear it every day. I've been watching the budgets up here. I think the first one, $4.9 million for Florida, and you think about the replacement costs, and you're saying, how do I meet these goals for sustainability? Because right now it's being placed against cost, reliability, and the access to knowledge. How do you make that balance work as a fleet manager when you're trying to meet all the objectives, when you're hearing numbers of 2 to 5 times the cost per vehicle if you go full electric? Our challenge here, and what we've tried to accomplish and have done very well in the market, is a just right solution. On the left, you'd see your traditional IC engine. You're all comfortable with it. You know what they do. They have some fallbacks, right? They do produce emissions. They are noisy. How you think about your drive profiles, but they're a known commodity. On the right, full electric. You've probably been studying about them, the challenges with them. The previous presentation, all about trying to figure out that right drive pattern, because you have a limited amount of range. What are you doing? You've got to be able to size that vehicle to meet that work environment. But obviously there's a lot of cost structures that come with that. What we're doing is called micro-hybridization. Eliminate all that idling. Handle all your support loads. All of that energy can be ran with stored energy on board a chassis without all the complications. And on average, most of the vehicles we convert, they actually have more hours than they actually have miles on them. And we see almost a 70% reductions in emissions on those vehicles. At the same time, you think about all the costs. And so for us, we're really focused on, when we talk about sustainability, the goal is sustainability should also not only be, it's a green, it should be economically sustainable, as well as ecologically sustainable. And this is where we focus. And I'm going to give you a couple examples of how that's worked. This was a fun one. Anybody make it to the Government Fleet Expo a couple months ago in May? This was a great little slide I just wanted to share with you when you talk about electrification fleets and why we're doing micro-hybridization. If you look at what it's going to take to put power in scale for large equipment, they're on the right, obviously mobile, there's a lot of energy and infrastructure that's going to have to be placed, and that burden and that cost has to come from somewhere. And then on the left, you got your light duty vehicles. Obviously, there's a lot of those drive lines that might make sense to be electrified. But the challenge is that's one of those cost structures that you've got to think about when you electrify that often is overlooked. And here's our example, the cost accounting. I heard accounting earlier, and here's another way you can look at counting dollars when you think about carbon dioxide savings. We like to look at it dollars per ton of investment. So if our goal, electrification, is really to reduce carbon emissions, we need to be smart about it when we think about accounting, budgeting, how we make that dollar go further to meet the real objectives. And obviously this is a fire truck. We have a lot of data on fire trucks. Still a work truck. It's designed to do a certain mission. On the left, you see a full EV fire truck. This is recently big news out in California, about a $1.2 million fire truck. In the end, what was the purpose? To replace one IC engine. If that IC engine ran for a full year, that's about 60,000 pounds of CO2 a year for a price tag of $1.2 million. That's $40,000 per ton of CO2 reduction. That's big to the books. For what we're doing, we work with OEMs, manufacturers, fleet companies, and we look at and we help them size their solutions, size an energy solution that matches the vehicle needs. Why? Because we can capture more CO2 for less money. In this case, you can see this vehicle, these are 16 fire trucks out of Canada, Toronto area, and build the same, they've always built, but provide this ancillary system on board. Upfront cost is about a $40,000 increase, but on how that vehicle is used, the fire trucks idle up to 80% of their time. Most of the time they go to a scene, they're actually just sitting there in for lights. They actually don't run the pumps. If you look at that savings, that's over almost 20,000 pounds of carbon reduction per year. So only about $4,000 per ton of CO2 reduced. So you can do more with less when you start looking about how I can spend that type of money across an EV. How can I spread that across my whole fleet in a standardized system? For this particular vehicle, we run everything: air conditioning, hydraulic loads, the tooling, the body lights, tank circular, everything but the main pump runs key off just like the engine be running. And we can do that with any work truck. Gives you an example here of what it looks like inside the vehicle, but I think this is the big part about numbers. When you look about the investment we made, you can see just on fuel savings alone, and with the economics it's kind of crazy to think, well, every day goes by, our payback gets even shorter. Most of our systems are now under a year payback. Could you imagine putting a solution on board that pays you back less than a year, creates real savings, reduces operating time on your vehicle, makes your vehicles last longer, and at the same time, you're cutting emissions? This particular vehicle platform, we got over 300,000 pounds of CO2 we know will come off on those vehicles over the platform. And I think we just had another order. We just did 16, and now we're doing another 20 trucks in Canada as another example of success stories. If you look around, we've been around quite a while on lift trucks, service bodies, tool trucks, diggers, we do pullers. Anybody that's traditionally had an IC solution on some chassis, even you'll see us all over in RV world, where that you're used to a generator, we're replacing that with advanced energy. Think of it another way of, hey, there's another form of electrical solution as an EV, but we're focusing on those smaller loads. Hybridization across the fleet. One of the other advantages here is no matter what the task is, if you've got a mixed fleet of all the different brands, different systems, all of our systems work across the entire fleet. They're all standardized, they all look the same, but you can scale them. So if you got one with more power, one with less power, they're all interchangeable. We've been in production now for over 7 years. All of them are backwards compatible. So this allows you flexibility in repair, maintenance. They're all low voltage. It's all low touch safe. So your maintenance crews can utilize it, work on it, install it themselves without having to have all of the new challenges around high voltage. All of this is designed to make electrification simple for all of you as you face the challenges of electrification. to hopefully get to lunch quickly. Come see us in our booth. If you're concerned about operational costs, you've got emission goals as fleet managers, you're looking at how you improve safety, you care about the reliability of your fleet, which I know you all do, but you're looking for different solutions. You're looking for range. One of the advantages here on emergency vehicles, the range extension is in the days in terms of reduction of fuel. Noise levels, or if you're just looking for electrification support, we have full-time engineers that support every customer. So when you're trying to understand and how to make a business case work, or you're trying to understand what the implications of your fleet was, we provide engineering resources to help you with that, analyze those goals. So come by, see us in booth 832, we're at the back, and we'd love to talk to you. So thank you again for your time, and enjoy your lunch.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.